All right, so today's lesson is going to be on linear and quadratic functions. All right, we want to be able to graph a quadratic. All right, and we're going to do that. Our objective, graphing linear and quadratic functions. The function g is defined by g of x equals 2x minus 3. All right? We said earlier that this g of x can mean nothing more than y. It's the same thing as y. All right? This guy is a function of x. So if I put a value in for x, I could get what the y would be, or what the function of x would be. Input, output. All right? I don't want anybody confused on the terminology. G of x is virtually the same thing as y. All right? Is everybody with me? All right? So this is a linear function. A linear function meaning a straight line. If the domain is the set of real numbers, then the graph of this is a straight line. Y equals g of x equals 2x minus 3, where the slope is going to be 2 and the y-intercept will be negative 3. A function f is defined by f of x, which is equal to mx plus b. This guy is a linear function. This is all review. Right? The function of x in mx plus b is a linear function, or a linear relationship. Okay? Everybody sees why the slope is 2 and the y-intercept is negative 3? We're good? That's review. Let's go to something new. Now consider the function h. h of x. And again, just think of this as y. All right? No need to get too mathy, but we need to get familiar with some of the terminology of function of. They call this function h. h of x. If you look at the function x squared minus 2x minus 2, what's the first thing that you notice that is completely different than what we've been dealing with so far? Go ahead. X squared. We have a square. All right? X squared. We now have something different. If the domain is the set of real numbers, then this graph is what we call a parabola. All right? A parabola generally will look like this in a coordinate plane. So I'm going to quickly sketch a coordinate plane. The sketch of a parabola would look like this. That's a right side up. This is an upside down. That's what a parabola looks like. Okay? So I don't have straight lines. I actually have curves in here. All right? This is completely different. All right? And we're going to try to relate this to what we already know about a coordinate plane and putting these things, graphing the points to help us here. A function f is defined by the function of x is equal to ax squared plus bx plus c. This is known as a quadratic function. Quadratic functions are parabolas. Now let's recall something. Linear functions were in the form of mx plus b. Quadratic functions are ax squared plus bx plus c, where a, b, and c are values, are constants. A and b being coefficients. The coefficient of the square term, the coefficient of the x term. Okay? If your A, important, if A is positive, then this parabola will open upward or look like that. That is a parabola opening upward. If your A is negative, then your parabola will open downward. Does everyone see? All right, that's a rule we have to follow. Okay? All right, so in your past you should have talked about vertex and vertices. Vertices being more than one vertex. To find the vertex of the parabola, you must solve for x. And we're going to give you a formula for that. Or a way to find the vertex of the parabola. Okay? If you had a triangle, all right, your vertexes or vertices, your vertex would be there, the vertex of the angle, the vertex of the angle, the vertex of the angle. We're trying to find the vertex of the parabola.